Good evening students. So today we'll study about precision wave rectifiers. So in that first part I'm going to tell you, that is saturating precision rectifier. I'm going to teach you today half wave rectifier. So this is the theoretical part that you'll have to make before coming to the lab. That is, one is the design part. You'll have to calculate what is my input, what is my frequency I've set, what is my CR1 and CRP1 I'm going to vary, and according to that I'll calculate my minimum and maximum gain. So these theoretical calculations you'll have to make. Input, whatever it is said in the lab, maybe 2 volts, 3 volts, like that you can take and make it. And frequency, start from 1 kilohertz, keep it as 1 kilohertz and do. And CRP1 is 1 kilo ohms, that is already given. Then this is the circuit diagram of saturation precision half wave rectifier. In the circuit you'll have to connect input, that is 2 volts I'm taking here, so to input side. Then this is my output side where I'm going to connect my CRO, and this is my variable resistance where I'm going to connect. So 1, 2, 3 points are those things which you people are going to connect. Other things of your op amp, then CR1, CR2 and diode, they're all internally connected. You need not make the connections. Here 3 points, that is your input, output and your variable resistances are important, where you'll have to make the connections. So make your connections according to your circuit diagram. And then here is the procedure that you'll have to follow. Make the circuit diagram, give the input, then observe the output. So this is a rectifier. So rectifier, it has got AC input and DC output. So this is my expected DC output, what you have to measure. So once you vary your CRP1, that is variable resistance, your output voltage should vary. So accordingly your practical and theoretical values should match. Here I will start varying from 1 kilo ohms to 10 kilo ohms. Like that the gain and the voltage will start increasing. How you increase your CRP1, like that your gain will start increasing. Like this your output voltage will also start increasing. So you did a design of this. Previously it said you that one, this your theoretical value you have to calculate, theoretical and practical value should match. So that is your experiment that you will have to conduct. Now I'll explain you what is there in the board and what you will have to do, how to make the connections. So here you can see I have a board here. So here this is my mains. I'm going to connect with a main plug. This is my transformer where 230 volts I'm going to convert into 12 volts. 12 volts I'll give it to regulator here. This is my AC regulator, and in AC regulator the board will still step down to 5 volts. So this is the board. This part of the board is getting only 5 volts. This is my regulator. This is my AC supply. From here 230 volts, here 12 volts, then at this end it is 5 volts. So 5 volts is given to all parts of your board. So here I have 5 experiments. So I will call it as A, B, C, D and E experiments. These are your A, B, C, D, E experiments. So for precision wave rectifier I am taking C part of the experiment. So it is the third experiment. So I am taking C part. So in this C part you will have connected diodes, connected resistors according to the names that is given in your circuit diagram. And this is my input side, CI1 input, 1, 2, 3, 4, 5, 6, like this. Then CRP1, that is my variable resistance, where I have to connect external resistance box. So that is 1 and 2, CRP1, CRP2. This is my output end, C0, that is 1, 2, 3, 4. These are your plugs where you'll have to connect. Using your screwdriver, you can open the screws of these things, what you can see, and then connect, insert the wire inside this. There will be a gap here, so you can insert the wire like this and make the connections. Okay, so here I've already done the connection and I'm showing you this. Before you connect your circuit, please set your AC signal generator. Okay, before you start your experiment, first make the AC sine wave signal generation. So here I have set, this is my voltage I've set, around 1.2 volts I've set, that is showing here. But when you do, please make the measurement in the CRO and take the voltage around 2 volts. This is my coarse variation, this is my fine variation. Okay, if I open this, minus sign will come, that means it is frequency. So I've put the gauge in 3 kilohertz. Now it is around 1 kilohertz. So 2 volts, 1 kilohertz, I'm going to perform the experiment. So that is what I'm showing you here, 1 kilohertz. If I press this button, that will show me my voltage. So please check this. It is around 2 kilovolts since the display is not good. So it is showing me 1 volt. Now it is around 2 volts. So for this, if you want your frequency, minus sign should appear. That means it is frequency 1 kilohertz. And I have taken a sine wave. So my output also will appear in terms of half sine wave. So that is your half wave rectifier. This is my input I have to set. This is my CRO probe I will connect to my CRO and check my input and set my input 2 volts peak to peak, then 1 kilohertz frequency. Next, we'll go for the setup. You can see here, this is my board. Since supply is on, so don't touch this part. Be careful with your board. Since I'm dealing with the AC here, be careful. So here I'm taking my plug. Here there's a transformer. This is converting my 230 volts into 12 volts here. And 12 volts is getting converted into 5 volts. See, when you perform the experiment, both the LEDs should glow. These two diodes should glow. Then only your board is in working condition. So please make sure of it. So when these two are glowing, that is my 12 volts is getting converted into 5 volts in the regulated part. So in this I explained you A, B, C, D and E. So I am doing experiment in C part. So this is the C part. Here I said you that I am going to connect input, output and a variable resistance. So this is my input side from the signal generator I have taken. So that is my from signal generator I have taken the probe, signal generator probe. So you can see I have connected it to CI1 and CI6. 1 is my positive, that is my phase side, and 6 is my neutral, that is my ground point. Then I will connect my decayed resistance box. So I have taken a decayed resistance box here. So that is my decayed resistance box, and I have connected here 1 kilo ohms. Okay, start from 1 kilo ohms, vary that till 10 kilo ohms. That is why I have taken the decayed resistance box, or you can take a potentiometer also. 10k you should take. So this is around 1k. For 1k I have to measure. So apart from that I have to connect the output side, that is my CRO probe. So here is my CRO probe. Okay, I have connected to C01 and C04. One is my phase point, other one is my ground point. So this is what I have done the connection, and this is what the IC I have used, that I have placed the IC looking at my notch here. So you can see there is a notch here also, or you can see there is a notch here. Okay, similarly only you have to fix the IC like this. So here was the notch, I have fixed the IC like this. So this is my IC, and you can see that in the board your according to your circuit diagram. Okay, this is my input end. So this is my input. I have taken input. I have connected C0, CI1, CI6. So I have taken CI1, CI6. Then this is the IC. So here I have my IC connected. You need not connect VS and VS points since it is already internally connected. Then coming to this one, this is also internally connected, and I have CR1 here. So this is my CR1 connected. That is 1 kilo ohms. Then I have a diode CD1. So here is my diode CD1, which is already internally connected. Then I have to connect CRP1, that is to CRP11 here. So I have taken a diode decayed resistance box, and I have connected it to my CRP11. Okay. Then other end of CRP11, that is your CRP1, it is connected to my C01. So I have taken my other end and I have connected it to my output end. Sorry, it is connected at my output end. It is quite loosened. So you can see now that is I have connected it to my output end, and the output side I already showed you. So this is my output. You can see that this is my output, and I am varying my rear resistance box. I had kept 1 kilo ohms. Now I am doing it for 2 kilo ohms. Now you can see the output voltage level is increasing. So it was around firstly around say 4 volts. Now it has raised to another 2 volts. So you can see that now it is at 2 kilo ohms. So for 2 kilo ohms I am measuring my voltage level. I can check this. Okay, for 2 kilo ohms you can see that 2 blocks are there. 2 into 2 it is 4 volts. Now I have increased to 3. So for 3 it has got again increased from 1 to 2.5. 2.5 into 2, that is around 5 volts it is there. So like that, if you increase some 5 readings you take. How you increase this? Even your voltage should increase. So every time you are increasing your 1k like that, then in the formula also you have to increase that CRP1 value and calculate the gain values too according to theoretical values. Then calculate your V0, that is your output voltage. Practically you have to note down for each kilovolts how much you are getting. This, lower this and you can measure how much ever if you go. It will keep on increasing. If I decrease, it decreases. You can see now it is getting decreased. So that is about your half wave rectifier. Okay, good morning students. As you know, in the previous recording we had said, that is experiment 8, the saturation precision rectifier, then precision full wave rectifier and dead zone. So in today's class we'll do with the dead zone. We did in the last class the half wave rectifier, and today's class we'll go with the experiment B, that is dead zone. So here you can see the dead zone. The aim of the dead zone is to study the op-amp circuit which can block a portion of the input voltage and remaining to appear out at the output. This is about the theory part. You can study it in the manual. Then you have the design part. So before you come to the class, please study this design part from your Lika textbooks. It is available. Then prepare your theoretical calculations. This is the circuit diagram that it is already internally built. So for this we are giving DC input, then AC input, then output CRO probes. So 1, 2, 3 are the connections. Other connections are already internally done. Okay, so you can see this circuit connection and make your circuit connection in the board. Then here is the procedure for that. Then what you'll have to record is, with the V reference, what is your practical output which is appearing on your CRO screen, you are supposed to note down. So that is the tabular column, you are supposed to do it. Okay, this is your AC input and also AC output will be there. This is how my output will look. This is voltage, this is time. So this is how my output will look. For your input, your output will be shown. Okay. Next we'll go for the board. Okay, good afternoon students. We'll continue with the dead zone. I showed you the circuit diagram and other things. This is your board where I have made my circuit diagram. This is my input side, DC and AC I have given. Then this is my output side where the CRO has been connected. Now I have setted my signal generator input as 5 volts 200 Hertz. I have used 5 volts 200 Hertz. So this is your 200 Hertz frequency what you are seeing. Now this is around 5 volts as your AC voltage. Okay. Then coming to your DC connection is being done. So since I have to vary my DC voltage and then take the readings, I have kept this knob at 0. Will start from a certain value. So this is your connection. This connection I have given it to here. So CIE 3 is connected to my input side. CIE 2 is connected to AC. CIE 3 is connected to my DC. Then other negative points are taken to 5 and 6 as a short points. Then here at the output side, I have taken CO2 and CO4 for my CRO connection for the output. Okay, you can see that output. This is the output what we have to get before we even start giving the DC. Once I start giving the DC, the waveform should shift. So that will happen. I will show you now. This is my output. So I am raising it. So here I am already raising it to somewhere around 3.3 volts. So you can see my output has changed from this level to this level. Now you measure your voltage. So this is for my 3 volts DC, that is my V reference. I am getting 1, 2, 3, 3.8 into here 10 milli is there, so 48 millivolts is my output voltage. So for 3 volts DC I am getting 48 volts as my AC output of your dead zone. So like this you vary this, so it will keep on increasing. So here you can see almost I have around 5 into 10, that is around 10 volts, 10 millivolts, sorry. So 10 millivolts it is there. So for almost 7 volts I am getting around 3.5 into 10, so around 50, that is around 70 volts we are going to get. So that depends on how much you give your V reference, that much your voltage will start increasing with respect to your dead zone circuit. Okay, then like that you record it in your tabular column. Increase for 3 volts I got 48 volts, for 7 volts I got around 70 volts, then for 8 volts I got around 80 volts. Like that you can keep on writing. Measure this as the voltage level and record it here. How you increase your DC voltage? Like that, measure your AC voltage on your CRO screen. So that is about your dead zone circuit. Good morning students. So in last class we had the experiment, that is your saturation precision rectifier, half wave, precision full wave rectifier and dead zone. Okay, in this experiment we have 3 parts, for half wave rectifier, full wave rectifier and dead zone. In the previous videos we have shown the half wave rectifier, then dead zone. Now today's class will go with the precision full wave rectifier. Okay, this is about the introduction. Now coming to your precision half wave rectifier, that is your C experiment. So okay, so in this we have the aim to study the non-saturation type full wave rectifier consisting of summer and a precision half wave rectifier. Using 2 half wave we have done a full wave rectifier. This is about the theory part, and this is about the design part that you will have to study in your LICA subject and do it before you come to the lab. And this is your circuit diagram. In the circuit diagram you will have to make 3 connections. One is your input, then one is your output, that is your CRO probe, the other one is the variable for resistance box. Okay, so here I am giving I have given 5 volts and 200 hertz as the frequency and voltage. Peak to peak I have 5 volts here, then 200 hertz. For this value I am going to show you the output. This is your full wave rectifier output, and here I have connected around 3 kilo ohms resistance box, which is a variable. As you vary this, your output will start varying. So that is what you will have to write down in your tabular column. The resistance box CRP1, CRP2 you have to vary. Accordingly note down your practical voltage values. Using your theoretical calculations, calculate your V theoretical value. That is what you will have to do in this particular experiment. Okay, now I will show you the circuit connection. This is your circuit connection. Here 1, 2 and 3 connections you will have to make. Other things are already present in the circuit in your PCB board. Okay. Now students, this is your signal generator from where I am giving VI, that is your AC voltage input. So here you can see I have set this for 200 hertz, and using this knob you can set your voltage till 5 volts. So here you can see that it is 2.4 it is showing. This is around half of your 5 volts. So only one peak it is telling me here. I have given 5 volts. Okay, then this is my 200 hertz. I have set this particular voltage and frequency. I'll be showing you the output. So here see I have connected this to CI 4 and 5. 5 as your ground point, 4 as your input. Then for this I have same point I have connected the CRO probe also to measure your input side. And coming to the output, so output I have given it to CO3 and CO4. 4 is your ground point, 3 is your input point. Next coming to the resistance box, this is your decayed resistance box where I have connected the leads, and this leads I have given one for CRP2 and then other one for CO3. CRP1, 2, and this is for CO3. So this is your resistance box connection. So this is your setup. You can see I am doing with a C experiment, and this is your output. You can see the output here, the rectified full wave rectifier output. So as I vary my decade resistance box, now here almost there is 30 ohms. So here I am varying with respect to kilo ohms. You can see that my the voltage level is increasing. Similarly, you can increase this in kilos, 1 kilo, 2 kilo, 3 kilo, like that. Your voltage waveforms will vary. So measure this much voltage waveform, say around 2 kilo ohms. The voltage what I am measuring here is 1, 2, 3, 4, 5, 5.6 into 1, that is 5.6 volts. Similarly, when I keep it to 3 kilo ohms, so here I am getting almost, I'll lower this, 1, 2, 3, 4, 5, 6, 7.2 into 1 volt, so that is 7.2 volts. Like that, for every kilo ohms increase, you can note down the waveform voltage levels. So that is your tabular column. So that finishes your full wave rectifier.